Hello friends, welcome to Learner's Planet. Friends, this is our fourth session for straight lines. In the previous session we discussed the concepts, the theorems and the terminologies related to straight lines. We discussed even some basic problems also. In this session we'll be taking more such problems from the topic straight line, and you also be ready with your paper and pen. Just see the problem as it appears on the screen, try to solve it on your own. This way you'll be able to practice in better manner. Okay, so let's begin the session. Now let's see this question. If equation 3x minus 4y is equal to 8 and 2px plus 3qy plus 12 is equal to 0 represent the same lines and the value of p and q are. Okay, see, in your junior classes you might have learned that if two lines are coinciding, then suppose I take example as a1x plus b1y plus c1 is equal to 0, a2x plus b2y plus c2 is equal to 0, right? If both the equations represent the same line, then a1 by a2 will be equal to b1 by b2 will be equal to c1 by c2. So the same funda will apply over here, right? You just have to be careful. Constant terms, either both of them should be on the right hand side or both of them should be on the left hand side, right? Otherwise you just change the sign accordingly, right? Now 3 by 2p, coefficient of x, coefficient of y, minus 4 by 3q is equal to 8 by, if I take 12 at right hand side, it will be minus 12. Okay, so if we take these two, we can get the value of p, and if we take these two, we'll be able to get the value of q. So that's pretty simple. So p is equal to 3 by 2 into 12 by 8 negative. Okay, so it is minus 9 by 4, and similarly we can calculate the value of q. So q, negative and negative will be cancelled. 3 4s are 12, 4 2s are 8, so q will be 4 by 2, that is 2. So p is minus 9 by 4, that's not there in the option, so it is none of these. Okay, pretty simple. Now if the line this and this be parallel, then now if two lines are parallel, their slopes are equal, right? So first of all what we do, it's 2x plus 3y is equal to 5. So 3y is equal to minus 2x plus 5. So y is equal to minus 2 by 3x plus 5 by 3, right? So it is y is equal to mx plus c format. So m, that is slope of this line, is minus 2 by 3. Okay, and slope of this line is m. If these two lines are parallel, then slope should be same. So m should be minus 2 by 3, right? And if the lines are parallel, see, if C is 5, then they will represent the same line, right? If C is different, they will represent the parallel lines. Okay, so C should not be 5 by 3, so the answer should be none of these. Now next important concept over here is the co-linearity of 3 points, right? Now 3 points co-linearity, that means suppose we have the 3 points over here, P, Q and R, right? Now how do we say that the 3 points are collinear? Okay, now so there are various methods to find out whether the 3 given points are collinear or not, right? We have 3 points P, Q and R having coordinates x1, y1, x2, y2 and x3, y3, right? Now we have to establish a condition where we can say that the 3 points are collinear. You might have learned the formula for finding out the area of the triangle in your junior classes. So that is the formula: half determinant x1 y1 1, x2 y2 1, x3 y3 1, right? Now if area of this triangle is 0, that means the triangle does not exist. That means the area of the triangle is 0. That means the triangle does not exist. That means these 3 points are collinear. Okay, so when the area of the triangle is 0, that means the 3 points are collinear. Okay, and one more very simple method: if the two lines are if the 3 points are collinear, then slope will be same, right? Suppose I have 3 points P, Q R. So slope of PQ will be equal to slope of QR will be equal to slope of PR, right? So you just can equate the slope. If the slope is same, then the 3 points are collinear. If slope is not same, that means the 3 points are not collinear. Okay. Here we take a question on the same concept. The 3 points, this and this will be collinear if. Now I assume the 3 points to be A, B and C. Right? Now what you can do, you can just equate the slope, right? I take the slope of AC and slope of BC, right? Because C is very simple, A is 0. So slope calculation will be very easy. So slope of AC should be equal to slope of BC, right? Now how do we find out the slope? Difference between ordinates by difference between abscissa. So 281 minus 0 upon 81 square minus A. That is slope of AC. Similarly, slope of BC will be 282 minus 0 upon 82 square minus A. Okay. Now 2A is cancelled. Here it is T1 upon T1 square minus 1 is equal to T2 upon T2 square minus 1. A will be taken out as common from both the sides and it will be cancelled. Okay, now just go for the cross multiplication. T1 T2 square is equal to T2 T1 square, and here it is minus T1 also, minus T1 is equal to T1 square T2 minus T2. Okay, we take everything on the same side. T1 T2 square minus T2 T1 square plus T2 minus T1 is equal to 0. Now we can take T1 T2 as common. T1 T2 common. Here we will be getting T2 minus T1 plus T2 minus T1 is equal to 0. So it is T2 minus T1 and T1 T2 plus 1 is equal to 0. So either this is 0 or this is 0. Okay. So T1 T2 is equal to minus 1 or T1 is equal to T2, right? But T1 cannot be equal to T2 because in that case both the points will be same, right? So what the other condition is, T1 T2 is equal to minus 1. Okay, so if the 3 points are collinear, then T1 T2 should be equal to minus 1. Then only the 3 points will be collinear. Okay. Now x1, x2, x3 as well as y1, y2, y3 are in GP with the same common ratio. Then the points x1, y1, x2, y2 and x3, y3. Okay, so what I do is I assume x1, y1, x2, y2, x3, y3, right? I assume x1 as A and y1 as B. Now x1, x2, x3 in GP with the same common ratio. So I assume it to be AR. It is AR square, then it is BR, it is BR square, right? Now we have to find out whether they lie on the same straight line, lie on ellipse, lie on circle, or vertices of triangle, right? So what we do is we first of all find out the slope. So it will be easy for us to decide, okay, whether the slope is equal or not. Now slope, suppose this is point A, B and C. So slope of AB is equal to slope and we find out the slope of AC. The slope of AB is equal to BR minus B upon AR minus A. So it is B by A, right? R minus 1 will be cancelled. Similarly, slope of AC is equal to BR square minus B by AR square minus A. So B will be taken as common from the numerator, A from the denominator. So R square minus 1 will be cancelled. So once again we are getting B by A. So slope of AB is equal to slope of AC. That means ABC, the 3 points are collinear. Okay, that means they lie on a same straight line. Right? The 3 points are collinear since slope is same. Now the acute angle between the two lines y is equal to 3 and y is equal to root 3x plus 9. Okay, so we know the formula for finding out the angles between the two lines. Tan theta is equal to m1 minus m2 upon 1 plus m1 m2, where m1 and m2 are slopes of the two lines, right? Now here m1 is equal to 0 and m2 is equal to root 3, right? Because this line can be written as y is equal to 0x plus 3, right? So slope of this line is 0. Okay, so tan theta is equal to 0 minus root 3 upon 1 plus 0. So it is minus root 3. Okay, we just have to take the modulus. So modulus will be equal to root 3, since we have to find out the acute angle. Tan theta is equal to root 3 when theta is equal to 60 degree. Precisely tan 60 degree is root 3. So the acute angle will be 60 degree. Okay. Now angle between these two lines. Very clearly we can see the value of slopes m1 and m2. So once again tan theta is equal to m1 minus m2. I will not write the formula once again. It is 2 minus root 3 minus 2 minus root 3, that is m1 minus m2 upon 1 plus m1 m2. So 2 minus root 3 into 2 plus root 3. So a minus b into a plus b, that is a square minus b square. So it is 1. Okay. Now 2 and 2 is cancelled. It is minus 2 root 3 upon 2. So it is minus root 3, and we'll be taking the modulus. So it is root 3 only. So once again tan theta is root 3, theta will be 60 degree. Okay. We'll be taking more problems in the next session. Do revise this session and the previous ones. Bye bye.